on standby here. Uh, so yeah, I'm currently an DB engineer at NVIDIA. Started in SSN. Yeah, நடுவுல தமிழ் பேசினா okay தானே, or is there anyone who only understands English? Yeah, just I think raise your hand if you are in the second category. Okay, I'm gonna assume. Okay, I'm just gonna assume எல்லாருக்கும் கொஞ்சம் தமிழ் தெரியும்னு. But yeah, please stop me if நடுவுல ஏதாவது like you don't understand something or not. I guess that goes for Rohit as well. Yeah, I'll let Rohit introduce himself as well. Yeah.
So hello, this is the other Rohit, the inferior Rohit. So this talk is like more. I'm gonna be like the other Rohit and not me. So that's why I'm here. So yeah, right now I'm in Bitsko doing my masters in microelectronics. I worked for 2 years and now wanted to get back in track in my life and here in masters. Yes, continue.
Okay, nice. Okay. Hold on. Yeah. Okay. Yeah. So there's always this thing about uh, what do you like அப்படின்னு ஒரு இது கண்டுபிடிக்கிறது. It's a very personal journey that everybody has. It keeps changing also. There's nothing wrong when it changes. So the first thing is when you find your domain, it actually never gets boring. Uh, you'll constantly try to find something new. That's how it always is. So you want to find that part of uh, your domain, right? அது உங்களுக்கு தெரியணும். And Goldilocks tasks. uh, there's this Goldilocks person, and you have to keep improving something, right? Everybody will have this one big dream about the future. I mean, like Kalam sir said, like it's always there. Um, if you find that dream scenario, you'll probably find your domain uh, aligned to that. It's not like you find your domain and then you find your dream. எப்பவுமே வந்துட்டு you will find your dream, and அந்த ட்ரீமுக்கு ஏத்த மாதிரி தான் you will do your domain search and all that, right? And it's never coupled with money. Usually if it is money, then you should probably not be doing engineering, I think. You should be doing commerce or something like that. ஆனா yeah, it will not be related to money. And definitely நீங்க core try பண்றீங்க, if you're doing anything related to core, you should know the money is not great when you start out. uh, I mean, you are உங்க கிட்டக்க இருக்க software people will be earning like way more than what you will be earning, right? That is always there. But then you should always know that uh, money comes secondary when it comes to like finding a domain. I mean, generally it does come first. I'm not gonna say it's not. But then in a long term, right? ஒரு 20 வருஷம் கழிச்சு, when you are in some big position, you wouldn't talk about money as your forefront thing. Uh, you'll be thinking about your like general happiness, what you're trying to contribute to the society and all that. Yeah. So for the guys who are not in your fourth year, please explore as much as you can. uh, Undergrad is the only place where you'll be able to like do multiple domains, random inter-domain projects, anything, right? You'll be only able to do that in before your fourth year. I mean, I put a question mark there because it's not always the case. நிறைய பேர் காலேஜ்க்கு அப்புறம் கூட பண்ணுவாங்க. Rohit 3 is a very prime prime example for that. Uh, yeah. Uh, Before that, uh, projects, right? Projects are your benchmark. You are not doing project to prove someone else that you know what you know. You are doing projects to figure out உங்களுக்கு ஃபர்ஸ்ட் தெரியுமா அப்படின்னு தான். People then see that and then they hire you. That is the secondary effect. If you're doing projects just to say that yeah, I want someone else to see my resume and be like, இல்ல எனக்கு இது வேணும். லைக் தே வாண்ட் திஸ். ஸோ தே ஆர் திங்கிங் தட் ஓகே இந்த ப்ராஜெக்ட்ல இந்த ஸ்கில்ஸ்லாம் இருந்தா ஐம் கோனா டேக். அதுக்காக மட்டும் தான் நான் பண்றேன் ப்ராஜெக்ட்ஸ். தட் வில் நாட் கெட் யூ அஹெட். பிகாஸ் if you do projects like that, you will do the same project that 20 other person has already done. But if you do projects that assess your benchmark, which is like uh, you have some technical skill that you're trying to use to make some project, it'll always help. You will think that it won't help. I thought the same thing when I was doing my final year project under KKN, and uh, every other project I ever did in undergrad. எல்லாமே வந்துட்டு எனக்கு எதுவுமே யூஸ் ஆகலன்னு தோணுச்சு. பட் யூ வுட் பி வெரி சர்ப்ரைஸ்ட் ஹவு மச் இட் ஹெல்ப் மீ இன் கெட்டிங் த கரண்ட் ஜாப் ஐ எம் இன் ரைட் நவ். ஸோ நெவர் ஸ்டாப் டூயிங் ப்ராஜெக்ட்ஸ் ஜஸ்ட் டு ஜஸ்ட் டு ஸ்பைட் யுவர் ஓன் ஈகோ. லைக் ஜஸ்ட் உங்களுக்கு வந்துட்டு உங்களோட டெக்னிக்கல் பெஞ்ச் மார்க் தெரியுமா தெரியாதா, அது ஒன்லி ஃபார் தட், நத்திங் எல்ஸ். ரைட்? I've listed some projects in this presentation as well. Like for VLSI, we'll be talking about it later. For embedded projects, I think there is already a Raspberry Pi lab in the curriculum itself, SSN lab. I mean, correct me if I'm wrong. Bianca, is that still the case?
Yeah, yeah, it's still the case. Sixth semester la we'll have IoT lab.
Oh, okay, yeah. Yeah, that really helps. At least like people who want to like just enter into embedded, just see it as a domain. I think now everybody is doing machine learning projects, so I'm not even gonna talk about it. I'm just gonna mention it and leave. Yeah, I'll actually ask Rohit this question. He'll know more about this. Yeah, Rohit, like tell what and all projects you explored. Like, how did you narrow down your field? I mean, you still have two other fields that you are looking at, but how are you right now on the? Can you describe your journey a bit?
Yeah, so if, just before I start that, in case you guys can't find your domain, it's fine, don't freak out. Now, masters on that, I still haven't found out my domain because I got introduced to much more fields and I'm again confused. So, like during college, I was confused on whether hardware is for me or software. So, software, I made websites and games using Python. And that was during my second year, I guess. It's been a long time. My memory has faded a bit. And then in third year, only I got introduced to Rohitram, and then we both tried to start off with that accelerator. Am I correct? Under
Yeah,
Genocide.
yeah,
Yeah, there was this cool MEITY, Ministry of Information and Technology. They hosted a hackathon where you had to implement innovative designs on FPGAs, and that's when this all started. So we didn't have much knowledge back then, and we just tried applying for it, and we just became good friends. Nothing came out of that though. And then the main thing was an E-Yantara. So this competition is hosted by IIT Bombay. I'm pretty sure all of you guys must be knowing because SSN also sends out emails for these competitions. So doing competitions apart from projects also helps you narrow down your interests. And E-Yantara is where we found out that uh, electronics is for me the passion. We did a line following and pick and place robot using a D10 nano FPGA, which is made by Altera, which is owned by Intel anyways. And we integrated like color sensors and then line following sensors and Dijkstra's algorithm in an FPGA. So when we started out, it was actually a pretty huge one, and we had no idea what to do. Like, and the coding standards we followed, all of that was so bad, and we just wanted to complete that project. And we learned about. Do you guys have Verilog in your sixth semester VLSI design? I forgot.
Yeah, fifth semester we have very log right now.
Okay, so like
oh,
make use of that lab and learn Verilog and to work on an FPGA. Try doing some cool projects, and they also put up a competition link in the coming slides for Verilog. So coming back, yeah. So after that, I wanted to join Rotaram to do a final year project under KKN, but because of circumstances, I was doing under KT Selvan sir, and that was also amazing. So we did under wireless communication, and that also inspired me to take up this field because a lot of VLSA technology use it in wireless. So all your 5G and even 6G right now is gonna come up. All those we use FPGAs and a lot of technologies. So yeah, back to you.
Okay, yeah, that's cool, right? Yeah. So obviously the question, like, after undergrad, what do you do? Masters ponuma illa you want to work? I Yeah, I just started work. Yeah, like I'm technically still a fresher, so I can tell you about the master side, but Rohit can definitely tell you about the like employment and coming back to masters, how it has all been, right? Yeah. Firstly, it's always personal preference. uh, you things you have to consider is before planning, like finishing your undergrad, whichever stage you are at, second year, third year, fourth year, even first year, like you should know that uh, undergrad kapro, it's almost like you are facing uh, stuff alone, and then you have financial matters that you'll have to attend to. some might have uh, some might have to support their families, some might not have to. So it's always a personal preference. That's always the first. You should always keep that as the first thing. After all this, you still have, like, you still considering masters or employment and all that. One thing you should know is, when you go into employment and you have actually found your domain, try to always do something related to your choice of domain, like something remotely related, at least. Try to do that always. It'll help you in the long run. You won't get irritated. If you're not get if you don't get irritated, you'll start doing better things, which will actually propel you more in your career. That's always the case. Masters level, you do masters only when you truly know your domain and you feel like, this is my domain. I'm going to go up. I'm going to do only this. I'm going to do interdisciplinary. I'm going to uh, get into, like, the research side. அந்த மாதிரினா மட்டும்தான் you do masters. It's not just for money. uh, it is true, masters க்கு அப்புறம் you get money. You get better money than what you got as a bachelor's, but in core industries, at least, masters will not guarantee that your money will just keep growing. It might actually ஒரு step மேல விட்டுட்டு it'll just leave you there, but after that it's still you have to put in effort, right? You can't just be like, masters படிச்சிருக்கேன், I should get more salary. You can't do that. Yeah. Like, if you are undecided, I would always say go the employment route. Like, like few years having work experience is pretty good. Is actually recommended as well. It'll help you in your SOP when you're applying for masters and all. In this presentation, I won't get into, like, the like entire master's journey, because yeah, I'm pretty sure I whatever I know is probably outdated. Uh, but yeah, before you go there, just do all the analysis first. Uh, do all that. It'll definitely help. Yeah. For some people, it's at least for me. When I thought about it, I felt like if I went to employment, I can't get back to studying. So that was there. But then, yeah, Rohit added this point where, like, you definitely would get that maturity in a master's course. But yeah, I'll ask Rohit, because Rohit went from hardware, from Zyma. He went to Optum, and then after being there for some time, he actually got back to ELSI. Yeah, I'll ask him, like, how is it in terms of, like, how's in terms of studying though? உனக்கு எப்படி இருந்தது, like, when going from like Zyma and the Optum, like the experience you got, how is it helping you right now? அப்படியே ஒரு give a guess, no? Just
Yep. So my first job was in a startup, and I was basically doing a whole electronic control unit by solo. So that was definitely the hardest job till now.
Yeah.
So there I learned a lot of stuff from PCB design, CAD modeling using Fusion 360 and signal processing. And even in the management side, like talking with the stakeholders and then giving demos and procuring goods and stuff. And I went on to build a team and then I left that company to join Optum, where I worked in Java, Angular. It was interesting for the first 1 year and it was definitely not that hard compared to working in a startup. So because you have a whole team and seniors sometimes will help you. And if you are lucky, they'll help you a lot more. So working in a team and having helpful seniors is entirely based on your luck. And ending 6 months was so bad for me because I couldn't feel the tangible like output. Uh, like நான் ஒரு வேலையை பண்ணா அந்த வேலை என் கையில இருக்கும். Like if you make a PCB layout or FPGA and then you see the output on the screen and then your device works properly, that feeling is amazing. So that feeling was missing in my software job. I was doing some financial related work and handling requests and stuff like that, but that did not give me true happiness. So that gave me a lot of motivation to again start, uh, like go back to VLSI. And last year only, I decided that. And Rohitram is actually a pretty good guy to go for doubts regarding your SOPs and stuff because he helped me out last year. So even
Yeah.
in like choosing whether to go to US or studying in India, I was very confused, and I decided to stay in India itself at the very last moment. So we'll come to that in the later slide. But now, yeah, like coming back to studies was definitely difficult because of one thing, money. So like 2 years you are in the work life, and at the end of the month you get money in your bank account, and that gives you a little bit of happiness. And then you look forward to the next month. So every weekend you would want to go out, have fun with your friends, and that kind of routine sucks. But once you end up in a college and you just have to let go of all those stuff in life because you'll be packed with projects, assignments, and then tests every other week. So,
Mm.
and kids will come directly from their bachelor's to master's. So you'll be competing with them, and that is pretty difficult because they will be in a flow. Like 4 years they studied and then they'll continue. Whereas you will have to again open a textbook and sit in a library and study, which you have never done in the past 2 years. So that mindset has to change a lot. So you have to be ready for that. And that took me about 2 to 3 months to get used to it. I'm fully not used to it. I still wait for my teaching assistantship money to show up, but that's not much. But yeah, these are the downsides of your uh, shifting from work to masters. But there's also upsides because it gives you more maturity. Like when I see people who came directly from their bachelors, they don't have the proper time management skills for projects, and they're not that serious in life. I would say, like no offense, it's just a generality, but there'll obviously be outliers. So that's about it. Next, back to you.
Okay. Yeah, that the last part is very important. Yeah. Yeah, we go to the next slide, please. So yeah, masters in India versus like US, for example, the main difference is syllabus and how they go about it. So when I did my MS here in USC, I had quite like I had a lot of freedom to choose my subjects. But then there is a downside to it. It will also like backfire if you don't choose the proper subjects. You always go for the easy ones. uh yeah, so that is always there. Secondly, yeah, it's there's always the component of cost to completion. Like a master's in US definitely will cost you a lot more than what you can do in like completing the masters in India. But people usually do it because you get return on investment. Like people usually like இப்படி யோசிப்பாங்க லைக் ஒரு இப்போதைக்கு I'm gonna put $55,000 or $75,000 எனக்கு வர ஜாப் வந்துட்டு இல் பி 120,000 per year அந்த மாதிரி கிடைக்கும் ஸோ ஐம் ஓகே வித் இட் ஐ கேன் மேனேஜ் இட் அப்படின்னு நினைப்பாங்க யா the other thing is I feel that the projects and like the research that happens here is since it's better integrated with the industry directly with the companies that are here, so my masters here would give you that uh, mainstream attention like whatever is happening currently you'll be probably working on some problem there. It is the same in India as well. But yeah, gate எழுதி இது பண்ணி only when you are in IIT Madras for VLSI at least. IIT Madras and IIT Kharagpur, I think. Yeah, Rohit can clear on that. Like you need to get all that and do right. I mean, if you really can, yes. But gate does not test you only in VLSI. It tests you in like signal processing and like embedded systems, which is all necessary. But still, like, why do I need to know what is like what does Fourier transform in like in frequency domain? What happens to signals when I add or multiply? Why do I need to know that? Not fully, right? I just need to know the VLSI part of it. Yeah, so that's always there. Yeah, questions I'll ask Rohit about this is like, yeah, since he's doing masters in India, like he can explain about what's happening right now. How are people like? How are your batchmates and all that? Yeah, please explain, bro.
Yeah, technically அவெல்லாம் தெரிஞ்சுக்கணும் because when you do projects like in your college or even in work, you might need to apply that, right? So
Yeah,
I'm
yeah,
not supporting Gate. அதெல்லாம் நான் support பண்ணல. I hate Gate. Worst exam.
yeah,
But yeah, you at least need to know the basics and stuff.
yeah. That yes. Yeah.
I mean, நானே கேட்டுக்கு படிக்கல, so அதனால I'm not the right guy to answer that. Yeah, there's a lot of
Yeah, but
difference.
hmm.
என்னது?
Yeah, but on the general, like, tell about like how are your projects right now? Like, அது எப்படி இருக்கு? Like, how are your batchmates? How are they responding? அதெல்லாம்
Yeah,
like
like
curious.
projects, I'll come to it. But before that, it's not just about Gate. There's also other methods. So like through Gate, if you want top 8 IITs, like less than 300 rank அதெல்லாம் வேணும் for MTech. And yeah, that whereas if you want to do MS by research, which is another thing which I think came like about 10 years back, I'm not sure. So quite a few IITs provide that. That's a 3-year course. So I think
Okay.
one of the juniors is doing it. I forgot his name. So for that, the gate score doesn't need to be less than 300. I think around 1000, even less than 1500 is enough. So if you guys are really into research, then you must go for it. And India also does have good research labs. So they do have like device fabrication facilities. If you're interested in semiconductor physics or even in fabrication technology. So like don't think that only US has everything, but India does not have. And there's also the last option which you can have, which is like bits HD or like self-sponsored. So these are pretty pricey. They cost like around 10 lakh, whereas your usual masters in by MTech through Gate will maximum cost you around like 2 to 3 lakhs only. So not many people come for the self-sponsored courses or bits. So self-sponsored, they keep their own exams and interviews. Only IIT Hyderabad does that. NIT Warangal and Suratkal, I think. So there's one more special mention also, which is Triple IT Hyderabad. So they do not even offer an MTech course in ECE. They offer only MS by research. Also a bit pricey, around 6 lakhs, I guess. And they do the best research in analog domain. Their digital is not that much, but they are one of the best in India for analog. So you might want to check them out. And of course, there's Triple IT Bangalore also, which is also around pricey, around 10 to 12 lakhs. So I mean, you get to be in Bangalore and study, so that's a good deal. And now the projects. So right now I'm doing a continuum robot, which is an embedded domain. Yeah, even though I'm in VLSI, I decided to do a major project in embedded field. So because I found the professor really cool, and then she had a lot of industry connections. So this is done under I think the Pro. I'm not sure. So a continuum robot, like you, is basically like you would have seen the Spider-Man villain. I forget his name. The power of the sun in the palm of my hands. He has this
Dog
very
cock, dog cock.
talk. Yeah, yeah. So you have to make a robotic arm which has a very fluid motion. So that is used in the medical field for entering very tiny capillaries or like in bendy situations, you could say. And the other project I'm looking forward to work on is MOSFET fabrication. So there is a device fabrication facility here, and there's like so much cool technology involved in how chip is made. And making a chip, I don't think India has. Whereas device fabrication labs are there, quite a few in India. So like starting from the silicon substrate, making the wafer, and then forming the substrate, the drain source. It involves around 700 processes just to make a single
Mm.
wafer. So
Yeah.
working with all these equipments and holding that device within the next 1.5 years, I am looking forward to that. As I said before, I like to have things in my hand, like a tangible object. And coming to my batchmates, so uh, I am yet to find someone who is of the same mindset as me, to be honest. Like, very few people come to study masters in VLSI for the domain. Mainly, people come for the money, to be honest. And uh, there's luckily a senior who's also called Rohit. So whenever I go in life, I end up meeting a Rohit who's always cooler than me. So, but
Sure, buddy.
unfortunately, only 6 months he'll be there. So he has also done cool projects on DFT, and I think he's from PSG. So you'll find people from all around India, and mainly Telangana or Andhra, which I'm pretty sure is the case in US also.
No.
No,
Slight racism there, but no.
do not cancel me. So yeah, the last 10 year is like 20, and then out of which like 10 is from Telugu states,
Mm.
which I have nothing against. I mean, I was in Hyderabad for 2 years and I had the best time of my life. So,
Okay.
uh,
Nice save there.
and one one thing I would like to point out is the usage of ChatGPT. Like the amount of usage they do, I just hate it. Like, so if you guys are using it, please do not use it. In case it's some repetitive task or you want to write a test bench, stuff like that, or you want to understand the concept, then yes, sure, go for ChatGPT. It's the best tool which can help you. Like, to be honest, ChatGPT teaches us sometimes better than the professors themselves. Whereas if you're doing a project or something, do not just copy paste the code. So I've seen what happens in real, like, so like almost 30% of 30 percentage of your marks out of 100 is for project, and the kids here what they do is they just copy paste the code, and sometimes it doesn't work, and they end up not completing it because they don't have a proper understanding of what is going on. So they miss out on marks as well as their own understanding of the subject. So please do not do that. Apart from that, they are a smart bunch with whom I have to compete for good grades. There's like people from NITs. I don't know why, like studying in NITs, and then they want to come to BITS Goa to study masters. And few people with work experience in Synopsys, NVIDIA, who are here. So coming to the difference between SSN and here, first is relative grading. So do you guys know what relative grading is? Like, Priyanka, do you know? Or I would.
We have relative grading right now, actually. 2025
What?
Oh,
rating. Yeah, we have relative grading.
Then fine, I
damn.
don't need to go into that. I feel that's good also. Like you don't need to get 90 out of 100 to get an A grade.
No, it's
So,
not that way. Like, and in a lot of subjects, like for example, DSDL 91 was A. Normally 91 would be O,
oh my
right, in
God.
absolute grading. So
Yeah.
yeah, like,
Yeah.
so that
Hmm.
happens also.
Wait, I thought relative grading means somebody who got the highest mark gets over, right? Yeah.
Exactly.
Yeah, so like, இப்போ வந்து there is a large difference between that person who got an O and the rest of the class. Now they will alone get O and
Oh,
everyone else will get
Oh,
A.
yeah, yeah. That is an issue with relative grading. Yes.
okay. Then I'm not going to say anything on that. Sorry to hear that.
Yeah.
And then moving on, it's the exposure you get here. So every other week, there'll be like 2 to 3 talks by people from industries or from abroad, and they come give their expertise on subject matters as well as opportunities. So like people come from the US, and last time they came from Korea, I think, like inviting students
Mm.
to apply for PhDs. And the third part is the usage of labs and academic freedom. So labs here you can access anytime from 3 a.m., 5 a.m. Anytime you want to, you can just get the key access and go sit in a lab and do your work. So this whole month, I was in the lab from 9 a.m. to 2 a.m. Because of 4 projects in 4 different subjects. This was one of the most hectic moments in the past few years for me. And I
Yeah.
enjoyed it thoroughly because of passion, whereas a few of my batchmates who are here for money, like they hated it. So make sure that you come to masters because of your passion and not money. Because a BTech, fine, your parents force you to study or peer pressure or whatever, like do engineering. You didn't have proper guidance. You chose BTech. Whereas masters is out of your own choice. So make sure you have true passion in this so that you'll actually enjoy it. And that's about it. Back to you.
Yeah. Yeah. So, yeah, more on the projects part. Uh, so for me, at least, I had this. I had projects that involved like creating an entire out of order CPU from scratch. I did. I also got. I also கொஞ்சம் diversified. I did like hacking and all, like all this fancy attacks that you have heard of, Spectre, Meltdown, அதெல்லாம் recreate பண்றது. I even like made made things better on that end. There was some research there. All this was very good actually. So many sleepless nights. Masters Nale, there is always this sleepless nights thing, but it was all worth it, right? Every bit was worth it. It was really good. So the whole mindset of if you're coming to masters, definitely know it. Uh, uh, I know it is a bit discouraging. Like you suddenly start having like doubts that do you really want it that much? See, even if you have a bit of spark, it means that you had that spark. You probably would be better doing a master's. Okay, so uh, just make sure that you are developing that spark. That's that's pretty much what we can say at this point. Then after fourth year, you get like after you start entering like the real workforce or masters, you'll probably understand what we mean, what growth means, seeing something tangible, looking at results, something that you studied being applied. That's definitely a better field than uh, doing something else. Yeah. Next slide. Yeah. That ends our general discussion. We are going into the VLSI specific, but under VLSI, there are a lot of fields. There is under the digital part, there is like the architecture, and then it goes to design, and then from design to DV, design verification, and then from there to DFT, which is design for testing. And then there is analog design as well, which comes in wireless. It comes in antenna design. It's kind of there in this. It's there in like almost every field kind of way. Mixed signal verification is a very big thing there. As Rohit said, fabrication is a very big industry that's currently taking shape. I think the Indian government is also trying to push fabrication a lot. uh, அது என்னது SEMI or Semiconductor Corporation of India? I so there is a government backed entity. அது என்னன்னு
நாட்
தெரியல.
ஷூர். இல்ல எனக்கு தெரியல. நாட் ஷூர்.
Yeah.
ப்ராபப்லி
So
குஜராத்ல வரும்.
yeah. Yeah, Gujarat has it, I think. I mean, let's not get into politics. Yeah, so fabrication is a very big thing. Everybody wants to have a fab. Everybody wants to have a design house. Yeah, Bianca, I think interned in a Mine Grove. Interned in Mine Grove. I always wanted to be there. Happy that somebody else is seeing to it. Uh, yeah, and then there's physical design. I think physical design you guys will be doing in your lab. Uh, Cadence Virtuoso, is it still the case? Uh,
Yeah, it's still the case. Fifth semester we'll have it.
oh, okay. Oh, okay, nice. Yeah, Virtuoso is very good. If you can do better projects in Virtuoso, believe me, it helps for VLSI at least. Whatever projects you do from your third standard, sorry, sir, third standard, third year, sorry, from your third year, whatever you do in third year, it'll definitely help in getting in your masters as well. Because all the accelerator stuff I did with Rohit, or like the final year projects that I did in SSN, uh, I put those in my resume because as soon as you come to your masters in US, you start your internship search. Even without any course, any US course on your resume, you start it, right? So whatever you did in your final year, whatever you did in your third year, it definitely helps. Uh, yeah. So please make sure that you figure out which domain under VLSI that you are interested for. And then there is always this misconception. I think it comes from this software domain where they think like testers is lower than front end developers or back end developers. I don't know much about it. I think Rohit can tell me. But yeah, there is always this misconception. Like the chip architect பண்ணவங்க தான் is more important than the person who's actually doing the fabrication. In VLSI or in almost any core industry, that's not the case. Yeah, Rohit, please tell
I
us.
mean, I guess it's because fabrication involves more about material science and chemical engineers, and
Yeah,
it's more of like a கொஞ்சம் லேப்ல உட்காந்து நிறைய லேப்டாப்பை தட்டுறோம், buttons, all kinds of simulation stuff. So
yeah,
it's a bit very intuitive and not like சும்மா லேப்டாப் ஃப்ரண்ட்ல உட்காந்து கோட் எழுதுற மாதிரி. So people put that down a lot, but that is a very interesting field. Like there's so much like Samsung, SSIR, and then Global Foundries, TSMC, like all these
yeah,
companies are involved in this. So that is pretty cool. So you guys can research on it.
yeah, exactly. That's always there. I mean, any all of these fields has its own research, right? You'd be very surprised to know how much research is involved in design verification. There is so much. I also had this misconception at the start, but then I did the architecture and design, and then I realized it's the same for everything. There are like when you enter a computer architect job as like the fresher you are or like 2 years experience, you won't be doing some very big thing. All you'll be doing is writing Python and running code. That's it. That's pretty much it. And design is even worse. You will be doing like NADQ and like signal connects. Like you have to ensure if two signals are correct connected or not. That'll be basically a job for the first 2 years. So I not first 2 years till you like gain like proper experience, which you don't know when it happens, right? Yeah. So VLSI is not like the software fields that you think. Uh, like you do yeah like you do something, you send it to someone, somebody does. It's like a collaborative effort. It always is. Like architecture talks to design talks to verif talks to architecture. It's a very mixed field. And yeah, current trends, industry trends are mostly DFT engineers are being hired more because it's relatively a new field. I think DFT on the I'm gonna say a decade or yeah, it's been less than a decade since DFT as a concept came to industry. Um, yeah. So yeah, what DFT is basically you insert registers in data path. This is for people who actually know what's happening behind the scenes. So you insert registers in data path and see if your data is actually coming in correct. Uh, if you have if you have remotely heard of anything in embedded systems, you would call this JTAG. You would call this core site. There are so many different names that people use for DFT. Uh, yeah. Also, right now, startups are hiring a lot, uh, like so much, because they've seen how this will help, right? Take Nvidia for example. They saw they did the yeah they were able to facilitate the AI boom, crypto boom. Uh, because of that, so much money came in, and yeah, people are like many startups are there, many design house startups. Uh, yeah. And one more thing is, I think I saw a question that Bianca forwarded me. There's this one thing like, how is it? How do you get into bigger companies? Many of the questions were like that. I think one main thing is when you get into when you're trying to get into bigger companies, it has more of it does not solely come from you. It comes more from the college's role. And sorry to say, SSN is very bad at core companies. I think your current fourth years would like attest to it. Like, yeah, it's very bad. That was one of the main reasons why I was like, yeah, I'm not gonna go to job here. I want to do my masters and uh, அங்கேருந்தே எப்படியாவது போய்க்கலாம் அப்படின்னு. So yeah, your college has a very main role to play. Uh, yeah, just make sure, or you have to go off campus, which is possible. I'm not gonna say it's not possible, but off campus, you should understand that people aren't very receptive. They'll ghost you. I applied to so many companies off campus when I was in SSN, Western Digital, Nvidia, Intel. Uh, Intel before it went bankrupt. Yeah, I applied. I mean, it didn't technically go bankrupt, but yeah, it's in a very bad place now.
I mean, off
Yeah,
campus go your college like எல்லாருக்கும் தெரியாது SSL பத்தி யாருமே தெரியாது. Like no one knew about it. What
no,
SSL was. So
but that is the thing, right? நான் அப்படிதான் நினைச்சிட்டு இருந்தேன். But when you go to any Bangalore college, that is even like in the same level of SSN, right? I think RVC, PES, there are so
location
many
matters lah.
colleges. Yeah, exactly. அவங்களுக்கு
Yeah.
வந்துட்டு சிலபஸ் ஆல்சோ இஸ் வெரி குட். லைக் அவங்க அவங்க சிலபஸ் நம்மளுக்கு வந்து ஒரே ஒரு கோர்ஸ் தான் VLSI. தட்ஸ் இட்.
True.
லைக் அட்லீஸ்ட் வென் வி ஹேட், இப்போ எப்படின்னு தெரியல, பட் இட் வாஸ் ஒன்லி ஒன். பட் இப்போ வந்துட்டு தெர் ஆர் சோ மெனி டிஃப்ரெண்ட் திங்ஸ் தட் யூ கேன் டூ ஆன் சைட் தட் ஆல்சோ ஹெல்ப். And காலேஜோட ரோல் லைக் இன் கிவிங் லேப் லைசன்சஸ் அண்ட் ஆல். ஸோ இப்போ இப்போ பார்த்தோம்னா SSN only has cadence ஓட license. We use Xilinx ஓட educational license, I think, to do the FPGA part in the lab. Uh, nobody uses Xilinx ஓட what is it? Vitas, Vivado. Nobody uses Vivado in like industry, right? They're all using Synopsys.
Yeah.
Yeah, which
Does
yeah,
SSL
which
have
is
other PCAT like Centaurus or Silvaco? அதெல்லாம் இருக்கா SSL like? Or did they bring it into curriculum or?
No, not yet.
Okay, it's fine. So that's
yeah.
related to the device level physics and simulations. Like the EDC course you study, right? On the silicon, PN junction times, all those stuff. So it's related to that.
Yeah, yeah, that is pretty sad. But please try to make up for it somehow, or do some course or anything. Yeah, which leads me to the next, probably last slide. Things you can do right now for VLSI. You can learn Verilog. It's there. It's available. Chipacademy.in, I think. Uh, there are so many websites that will teach you Verilog. If you are planning to do design verification, if you're trying to get into this field, UVM is it's pretty open. It's technically system Verilog now. It's a system Verilog with a structure. So learn UVM. Uh, so right now there are I talked about startups, right? So many startups are using Riskvi because it's free. Anybody can use it. Anybody can develop on it. Uh, and if you are even if you're trying to get into embedded or anything related to firmware, please read through Intel's x86 register set. It's very helpful. Even if you do not know the background of computer architecture, uh, knowing register set will make you a very good software developer, and it'll like help you gain more in your career, like people who are still into software, right? I'm telling for them. And you would be surprised, people here use Perl more than Python. uh, I think it's a industry legacy thing that nobody has ever phased out. So many people use Perl, uh, and there are people who use even tickle scripts, TCL. Uh, I don't know what's going on in their minds. Absolute mad lads. But yeah, learn Perl. I'm pretty sure you guys all know Python. First year, like, you guys would have had like a Python course. But yeah, do a Python project. Perl, yeah, just know Perl. You don't need a project on it. Yeah, and there's this Jane Street challenge for FPGA. There are so many student challenges or like open challenges in the wild that you can do. You can start now. It doesn't matter, right? Just enroll. Just try to get some exposure. You will always learn something new. So when I did Yantra with Rohit, I thought I knew everything about Verilog. Like I was at the peak, but it wasn't the case. It was
ரெண்டு
yeah.
பேரும் பயங்கரமா அடி வாங்கணும் பேசிக்லி.
Um, it was a very humbling moment. Yeah, always try to get into any possible challenge that is there in the internet. I mean, if it's free, just get into it. It doesn't matter. But if it's gonna be paid, like think about how much you'll pay to get exposure, right? Uh, yeah, that is a very good thing. I think we also had this microprocessor challenge when like they told us to develop a Riskvi design for using their Swadeshia. No, no, no. What is that? Shakti processor, Shakti and Vega. They told us to develop using that. I
Oh
don't know
yeah,
if it's still
IIT
there.
Madras, I think.
Yeah,
Yeah.
it's
And then
actually good
Sony
that you
Express
guys
or
are near.
something. What was that?
Oh yeah, that was Sony, la.
Yeah, Sony.
The Yeah, it was an embedded systems project though. It was not fully
ஆமா.
VLSI, but yeah, that was also very good.
And very hard. Oh my god.
Yeah, yeah, it's good memories. At least like get a band of friends like to get into all these challenges. It's
Actually,
actually very good.
keep a guy for software also, it'll come in handy.
Yeah, yeah, it'll definitely come in handy.
Yeah. You
Somebody who
guys might
wants
have
to
heard
like
of
go
Ramnath.
the IT route though. Yeah,
Ramnath, maybe you guys have heard. I don't know.
yeah, he was the web dev domain head when we were there in 2023. He's not a domain head. He was there. He was just there, I think. Yeah. Oh yeah. One main point is LLMs are your friend until they are not. Uh, they'll help you, right? Uh, LLMs, like if you understand machine learning, like if you know how it is there, I'm pretty sure everybody knows how it is working right now. LLMs are trained on public data. So LLMs can take you to one point, right? அதுக்கப்புறம் they won't know anything. And for core, especially for VLSI, all
Hello.
LLMs are bad.
Ah, it is still going
Claude,
on now. If you want to come and say hi now, you
Sorry,
can still come.
Claude,
That's what I wanted to tell.
GPT, Gemini, everything is bad, very bad, because there isn't very good public data on
Yeah, yeah, yeah,
like
sure, no
VLSI, and
problem.
VLSI in itself is very
Stereotype. Get
different
back
than
because
software,
I'm
because you
like
have to
doing
think in
the recording and other stuff, so I
uh,
have to go.
parallel processing
Bye.
rather than sequential, like
Yeah, okay, bye.
how you do in software. So use LLMs to frame
Huh?
problems. Like if you're searching for project ideas, use LLMs to like figure out.
Yeah,
But
yeah,
then
sure, sure, sure. Mm.
அதுக்கப்புறம் don't ask it anything. Like because after that they also like the LLMs
Which
also will
thing?
not know how things
Like
work.
general, I mean. Like,
It'll definitely help you if you can give it a basic skeleton. It'll help you fill in the holes, like what cursor or all those IDEs do right now. I think VS Code like there is this GitHub Copilot.
yeah,
It'll help.
yeah,
It'll
yeah,
definitely help
yeah.
you there, but it won't help
I
you to
mean,
do
short
everything from
answer is
scratch,
it's
right?
not going
Just
that good, but still I'm
just know
trying.
that.
Like, I'm not giving up that
And
stage,
yeah,
but still it's
if you're
going on
someone
like that.
who's in
Ipoldeke, I don't
VLSI who
know. Like,
wants to try
Ipoldeke,
out
it's
VLSI,
looking like NAT
if you
is
want to
very
try
much
out VLSI,
formative, but
start with
I'm
D
trying in
flip
other
flop.
places
That's the
and
easiest thing
hoping
you
for
can
the
do.
best.
But then yeah, if you're someone who's already like knee deep into VLSI, try making a dual clock FIFO. It's like input clock la ஒரு frequency and output clock la இன்னொரு frequency. Uh, so you put in data in one speed and then you take out data in another speed. You should ensure that underflow doesn't happen and overflow doesn't happen. Yeah,
Okay. Okay, I hope
you
so.
can do all
I
this
don't
to
know.
figure
I
out
was thinking like Janல
where you
வந்து
are in the
there's this
VLSI
internship
field right now.
start ஆகும். அதுக்கப்புறம் they do
I
the
think
hiring
that's
method.
exactly
Like,
1 hour,
continuously it will
and
go.
then we are done.
I don't know.
Any
ஒரு
questions for
நிமிஷம்
me
they're
or
calling me.
Rohit? Please go ahead.
Yeah, so like thank you so much. That was like really informative and we came to know about a lot of things. Like if anybody has any questions, you can either put it in the chat or you can put it in the Google form. I can read it out for you, or you can even like unmute and talk. It's fine. But just make sure that you're not interrupting anyone else. That's all.
Yeah, yeah. One other thing is, please don't be afraid to ask questions. Like regardless of however you think it's dumb, it probably is not. Don't think that you're doing it for yourself. When you ask a question, you're probably solving someone else's question as well. Uh, yeah, it took me so much time to realize that, but now that I do, I am asking weird questions. So yeah,
I'll ask you a question. How is life at NVIDIA?
how is life at NVIDIA? நல்லாதாங்க இருக்கு
Oh
ஒன்னும்
my god.
ஒன்னும் என்ன 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 சொல்ற என்ன என்ன மாதிரி கேக்குற ஹவுஸ் லைஃப்னா
இல்ல
என்ன
like
டெய்லி
I
போய் ஜென்சென்ட்
want
ஹைஃபை பண்றேனா
No,
Rampa
like
Bhatia.
I wanted to ask, like, இப்போ வந்து you already had like a little bit of experience working at Zyma, like during your internship over there. So you know that or a
yeah.
like or a startup la வந்து how much freedom you have to like bring your own ideas and do your implementation like in Zyma or MindGrow, and like how it's different in an actual corporate environment like Nvidia. Like how is it feeling? It's like
Oh,
conflicting or like you get to put your implementations also on the very one.
okay, okay. That's a good question. So Zaimala, my team leader was Rohit, so I didn't have to worry
I,
about who I was reporting to.
oh,
So
இதெல்லாம்
yeah,
நடக்கவே இல்லை.
huh?
இதெல்லாம் நடக்கல, யாரும் நம்பாதீங்க.
Yeah, நடந்தது. This guy is being too humble. That's it. So yeah, so Zaimala வந்துட்டு it was a very open thing, right? Uh, we just had the problem statement on hand. Uh, it was just a high
Yeah.
speed data acquisition. அவ்வளவுதான். Like you do anything you want, you figure out any possible architecture you want, any design you want, any uh, like you do whatever you want, just get this done for me. அப்படின்னு தான் எங்களுக்கு கொடுத்தாங்க task. Uh, so Zymas was more of like conceptual at we had to see எப்படி வருது and all. And அப்போ both I think me and Rohit did not have like proper Verilog knowledge. We were just like trying
ஒண்ணுமே
to do
தெரியல, to be
எப்படியோ
honest.
பார்த்து பண்ணலாம் அப்படின்னு. Yeah,
It
yeah.
took us what, 1 month to interface, not even interface, I mean, inbuilt, you have inbuilt ADCs in your Xilinx FPGA board here labs also. So அது நாங்க பண்ணதுக்கே we took about 1 month.
Yeah. Uh, and for me, it was distant to office also. Even நடந்தே ஆஃபீஸ்க்கு போனோம். I had to take a car for,
நடந்தெல்லாம் போல சைக்கிள்ல போனேன் எப்பா.
but still, I had to take a car for 40 minutes. Beats that. Yeah, Zyma is, coming back to the question. Startups will always give you more experience or round all. Um, but then corporate life, like how is it in NVIDIA, will give you more of like industry standard. See, when you are in a startup, you are not technically competing with the big guys. You're just trying to get into the market, position yourself there. So you don't care about how it is done underneath. You just care about if you're getting it in. That's it, right? But then when you are in corporate, it doesn't. Yeah, when you are in a big company, I don't want to say Nvidia as a corporate, but it is. It's basically a big startup again. Nvidia is like a big startup. Uh, very less people in the team again. Yeah, and team like there's only like some 15, 10 to 15 people, including the manager. Uh,
Isn't that a lot? What?
no, but like take Apple for example, right? Apple or
Oh,
Samsung or any other design house. 10 15லாம் அவங்களுக்கு வந்துட்டு இட்ஸ் a very small number. Like
oh,
அவங்களுக்கு டிசைன் மட்டுமே அவ்வளவு பேர் இருப்பாங்க.
oh, okay.
நான் வந்துட்டு I'm saying everything, include everything, right? Like include design, include verif, include arch.
Okay, maybe I was comparing with software, and then I got a shock. But yeah, continue because I mean my team was like what 6 or 7 people in software, but yeah, it's different in hardware. Continue.
Yeah, so இப்படி பாரு, like we 15 people are responsible for the entire LP, like the sorry entire memory controller of the IP, right? Like entire memory controller IP.
Yep, புரியுது.
So yeah, that is yeah, that's why I will say Nvidia is a big startup. It's not a corporate. It's technically not a corporate. But yeah, the one thing is Rohit is சொல்லியிருந்தான் முன்னாடி. You will have help from seniors, a lot of help from seniors actually. If you are in core uh, software, I don't want to comment, but uh, in hardware at least you will have a lot of help from seniors. How is it for you, Bianca? Like, you did mind grow இல்ல உனக்கு எப்படி help பண்ணாங்களா எப்படி எப்படி?
Yeah, like to be honest, like probably like proper. I like end of first year la I saw a lot of seniors from like through tech club and other things. Second year la I used to attend tech club classes and other things regularly, and I definitely came to know like, oh, idala I can do, I can implement, and I started working on those things and other things like that. And yeah, like ippo kuda if I'm confused about something, I like there is always some go to people who I can call and ask and other things. So like SSN la that thing is like definitely there, like you can go and talk with any senior and things like that. Like when I was doing my internship also, like a lot of people who previously studied at SSN were there. So like
Oh, okay.
I was like working on this entire project fully by myself, and there was like no documentation, and LLM was also giving like
Mm.
random answers. So I had to sit and break my head and Apollo like talking with seniors, and I was talking with so many people to get some input and finish my project. So that was so helpful at that time.
Yeah, yeah, this is very good, right? Daniel இன்னும் அங்க தானே இருக்கான், Daniel Mark Isaac.
Like one day I made him sit and he was helping me debug one issue for so long. Like ஒரு evening 3
தங்கமான
o'clock ல
மனுஷன் அவன்.
இருந்து
Yeah,
3 o'clock ல இருந்து 6:30 வரைக்கும் he was sitting with my issue. Poor thing.
yeah, yeah, that is still the case. Like I think எல்லா இடத்துலயும் அப்படிதான் இருந்துச்சு, except for Zyma, because Zyma there was nobody senior to us who could help us. நான் போனதுக்கு அப்புறம் I think Rohit probably had some help, but
யாருப்பா
I
சொன்னா?
don't know. இல்லையா? சரி, ஓகே.
யாருமே இல்லை.
Yeah.
தனியா கார்னர்ல அழுதுட்டு இருந்தேன் அவ்வளவுதான்.
Yeah, crying is always there.
Yes.
Okay, so I see something in chat. Any suggestions on the type of resume to build for internships and how can I approach companies? Okay. Type of resume. Uh, there isn't a type of I mean, yeah. If you are doing multiple domains, you'll have multiple resumes. I think. Uh, you'll have one with you have one for hardware, one for software. I think Rohit had like three, something like that. One for software, antenna, and then hardware. Uh,
Yeah, like company பொறுத்து make a resume and
yeah,
then
if you if you are thinking about internships specifically, you should technically you should build a resume for the job. You don't build a general resume and then you put. Uh, but yeah, internships you can just put a lot of projects. I think there is this one overleaf template in resume that I think everybody uses. That is very good. Jake's resume.
come on,
Uh,
open up your resume.
no,
Don't be humble.
I
Open it
am
up.
not. I am not doing that. No. லிங்க்டின்ல இருக்குமே. I mean, அதுல இருக்கிறது தான் என் ரெஸ்யூமேலயும் இருக்கும்.
The latex format that one you're talking, right? Overleafல இருக்கிற like
Yeah, yeah,
latex
yeah. Jake's resume latex ஆமா.
things or something like that.
Yeah. Yeah, அதுதான். That's a very good template actually. அதுல ஆனா remove the work experience. Uh, I would remove the summary as well. Uh, yeah. You can actually see a lot of people online that does it. And if you're coming from masters, there like even the university itself will help you do the resume. Like it'll give you like this master class talk on like how to make a better resume and all that. Uh, yeah, I think that finishes first part of your question. How can I approach companies? This is a very tricky part. Usually, core it is mostly you will have to get referrals. You at least இங்க it's referral game. I think இந்தியால வந்து it's more of like நீ எந்த யூனிவர்சிட்டில இருந்து வர and how are you approaching the general exam, I think.
Yeah,
Uh,
there's that written exam and stuff irritating.
yeah, I think நம்ம பேட்ச்ல இருந்து சிலிகான் லேப்ஸ் போனால ஸ்ரீஹரணி.
Yeah,
Yeah, it was like that only அவங்களுக்கும். They had to like sit down, they had to write and written exam. அதுக்கப்புறம் அதுல எப்படி வருதோ அப்படி தான் போச்சு. But apart from that, if you want to do off campus Ashwath, I would say just go to the just go to anyone there. You if you know someone there or like approach someone in LinkedIn, introduce yourself, ask about them, ask about how they are moving forward, how did they choose this career and all that, and then slowly get into the question like, do you have any openings in your company that I can that you can refer me to? அப்படிதான் யூஸ்வலா போகும்.
also you can use SSN or alumni network. Like you can like cold messaging random person will be less effective. Like specifically SSL படிச்சா அந்த கம்பெனி போறவங்க will be more likely to respond. You can
Yeah,
start off with Rohit Ram also.
yeah, but like when you try to like message me like anyone, right, not just me, right, like please be like not related for the job, like try to ask more about the field instead, because like imagine you being in my place and then you suddenly see someone messaging saying like Anna, hi Anna, I want this, can you tell me அப்படின்னா it feels like நான் இப்போ உட்காந்து இதுக்கு நான் ஆன்சர் பண்ணியே ஆகணுமா அப்படின்னு ஒரு தோணும்ல. ஸோ தட்ஸ் ஆல்வேஸ் தேர், ரைட்? ஸோ whoever you're cold messaging, like I would say like if you're doing LinkedIn, என்னைய பண்றதுக்கு பதிலா you can actually search for managers and then just shoot them questions there. You would be surprised, so many managers are very open. Like they want to talk about their career, they want people to get in. Um, Professors as well. I think நம்ம போனதுக்கு அப்புறம் there were so many of our juniors who just cold emailed IIT professors and they were able to get like a lot of research positions. நம்மளுக்கு கோவிட் வந்து எல்லாத்தையும் காமெடி பண்ணிடுச்சு. பட் oh, where would I have to start in order to get specialized in hardware as a first year? Okay. Uh, as a first year, okay, I'm actually stumped. Rohit, any thoughts?
I mean, first year itself, specialized. Hardware has
Yeah,
a lot of stuff,
actually,
like specifically VLSI or embedded.
yeah, the hardware
Yeah,
now, where do
you
you
got to
say?
find out.
Yeah.
So easiest thing to start off with, of course, yeah, like Atmega and then Raspberry Pi, because
Uh,
those are more related to what you study. Like, I guess you study Python in your first semester, and in your second semester you study C plus plus. I don't think you study C. So you can integrate like or sensors with the chip, make some cool kind of robot or implement machine learning models. A
hmm.
basic your what is that Python notebook in Jupyter. So I can start off with that and all the edge detection, face recognition. Those are all very basic machine learning models which you can understand and implement. So I can start off from there and then move on to more uh, fields like Verilog and FPGAs because
Yeah.
that is
Uh,
slightly harder to understand. Like it is easier for you to jump into Verilog by having a little bit of background in coding.
yeah, that's always there. Yes. Actually, embeddedly, how do you think though, Rohit? Like,
Yeah,
embeddedலயே வந்துட்டு ஆட்மேகாலாம் கொஞ்சம் உள்ள போற மாதிரி தான். இட்ஸ் நாட் ஈஸி இல்ல, லைக்
yeah.
டக்குன்னுலாம் வராதுல்ல, ரொம்ப உட்காந்து மூளையை கசக்கணும்.
I mean, Arduino is like even school students do Arduino, I guess.
ஓ யா யா ஆர்டினோ இஸ் a
I
very
guess he means the bare metal programming for like Atmega chip வச்சு பண்றதுன்னு நினைக்கிறேன் 8-bit program.
அதான் அதுக்கு வந்துட்டு ஐ திங்க் இன்வெஸ்ட்மெண்ட் காஸ்ட், லைக் த இனிஷியல் இன்வெஸ்ட்மெண்ட் இஸ் அ பிட் டூ ஹை. யூ நீட் லைக் தட் எஃப்டிடிஐ, அதுக்கப்புறம் அந்த
Oh, oh my god.
இன்டர்ஃபேஸிங்லாம் தெரியணும். யா ஐ வுட் சே அதான் எஸ்பிசிஸ் தான். இந்த இந்த ஆர்டினோ, ஆர்பை, ஐ திங்க் தட் வில் ஹெல்ப். தட் வில் டெஃபினெட்லி ஹெல்ப்.
நம்ம காலேஜ்லலாம் இல்லையா? I don't know.
ஆர்பை இருக்கு,
There
ஆனா
was there.
ஆனா அட்மேகாலாம் பண்றது இல்லைல்ல, லைக்
I don't remember.
Like syllabusல we don't have, but it's there in the college. Like they get permission from like the relevant faculty. Now they can use it, like node MCUs and other things. Like there was this one time when I saw like that TM4C 123G, அப்புறம் MSP 430. அதெல்லாம் கூட it's there, but people just
ஓ
don't know and use it. Yeah.
ஓகே.
MSP Futuri is pretty cool. Like DSP processor தானே அது.
ஆமா.
Like
Then
TM4C 123G is also like similar to that. Now, you can do a lot of digital signal processing.
yeah,
Damn.
I guess from Arduino you can jump to that and then like more
Yeah, but for a
Verilog and stuff.
first year, they probably are not gonna go to MSB.
True.
Yeah, yeah. I would say for a first year, I would say just go the Arduino route. Get an Arduino. I think there is like that. That's another off-market ones. Beagle board. Okay, that's RP.
Beagleboard Black.
Arduino. Yeah, yeah. Beagle board black. That's actually very good. If you can't get an RPi, Raspberry Pi, get a Beagle board. Even as a first year, it's very good. Even for software developers, it's very good because it'll help you learn all that networking stuff, which many people don't like. I mean, I like it, but I don't know why people don't like it. Yeah, I don't know if that answers your question, Santosh, but yeah, cool. Okay, Kumaran asked, I'm in my first year, interested in core VLSI and embedded systems. I don't know how to start
I
and
mean, isn't
doing
it
projects.
similar? He's also in first year and hardware projects. Like, do you have
Nice.
anything?
Santosh in first year though. Like,
No,
you don't
Kumaran.
know. Oh,
Oh,
okay.
my bad.
Yeah, but I don't know how to start and doing projects. Can you share how to start? How to start? Yeah, I have same question, same answer. Start with Arduino.
Amma, I'm having
See if you
work.
like the embedded vibe because it's a lot of data sheet reading. It's a lot of internet தெரியாத answers you will have to figure out. Something that you won't. Your chip will have some problem that only you can figure out. Many people might have had the same problem, but Like you will have to experiment a lot. Um, yeah, I would say just get an ESP32. Arduino அளவு கூட வேணாம். ஒரு ESP32 எடுத்துட்டு like that fully developed ESP32. Yes, yes, somebody makes it, right? 5 rupees இல்ல it is very cheap. 15 rupees என்னமோ தான் நினைக்கிறேன்.
No idea. I mean,
Yeah.
that's cool.
Yeah. Robo.in.
Do you mean the ESP01 or is it something else?
Yeah, yeah, ESP01 தான். ஆமா.
Okay.
200 இப்ப என்னன்னு தெரியல. I don't know. It's a very good starting point. Like அதை வச்சுட்டே you can do a lot. And even if you fry it ஒரு 100 rupees போன மாதிரி அப்படின்னு வச்சுட்டு விட்டுறலாம். ஒன்றும் பிரச்சனை இல்லை. Arduinos are harder to fry, I
Learned
think.
experience.
ஆமா. Yeah, start there. Yes. Oh yeah, because they bought
Qualcomm.
Sridhar with the facts. Qualcomm வாங்கிட்டாங்க.
Okay, so like I wanted to ask, இப்போ வந்து like for embedded systems and VLSI க்கு வந்து if like juniors are trying to focus on open source projects, like is there like any suggestion that you would like to give to them? Because you know that MNCs and all like really look up to like open source projects, right? Like they get a good shot if they are good with that.
Yeah, no. Not in VLSI at least. Open source projects are not that great when it comes to MNCs or like any big design house because uh, current open source EDA tools. I think there's one thing called OpenCAD. I keep forgetting its name. Uh, OpenFlow. Uh, there's this entire
Open road
flow
தானே?
from Open Road. Yeah, Open Road. Yeah. Like Open Road, vachi, if you can make something, na, very good. But learning Open Road should not be the point. So, அது மட்டும் ஞாபகம் வச்சுக்கோங்க because nobody is using open source tools inside the industry, right? You have to understand that. They are all using EDA vendors from Synopsys and Cadence. So, labல இருக்க Cadence is very good. If you can make like a adder, if you can make a 2-bit adder with the Cadence Virtuoso full custom layout, if you understand everything, DRC, you understand the width, sizing, எல்லாமே, if you can understand and do that, it's a very good project. You can include that. It's really good. But then generally, with Open Road, you make some synthesizable design. That's very good. But then, if you just learn Open Road and then you contribute to Open Road, you are targeting the EDA industry, and EDA industry is very, I would say, is very concentrated. It's literally a duopoly. So yeah, but yeah, do a lot of open source, like publish your projects though. Like do any, like choose any project that you think is hard, and then just put it in GitHub and then write about it in your resume. That is more than enough. Like that is the open source part of it, right? Any somebody can come look at your code. அவ்வளவுதான். It's not like in software they'll come and like look through the app GUI or something. But then if you can put some waveform, uh, it'll be very good. Yeah, I see the Darshan already has mentioned Icarus Verilog. That's very good actually. It's a very good open source Verilog compiler. Yeah, you can use one of those and like generate waveforms. I think there's this app called GTK Wave. You can view the waveform as well. And update GitHub you can upload the waveform. So I would say make your Git in such a way that you have all your code and then you have waveform to show what you did and like some diagram, block diagram on how did you decide upon all that. That is the open source part of it, but don't think that Open Road itself or Open Road or Magic Editor or all these tools. Just don't focus on the tool uh, because nobody is using the tool inside the industry. at least in the top design houses. I'm not sure how it is in uh, like established startups like mine. I don't know how it is like that. How's it there? I remember Daniel said they use blue spec Querylogs for verification. But
Yeah,
அதுக்கப்புறம்
still do that. Like, they still like tools like EOSys and other things. I'm not very sure because like I was
yeah,
with
yeah.
system software, so
You
uh,
okay.
Vara, like, I'm not sure.
Yeah, yours
GTK
is
Wave
actually
they
comes
don't use.
under sorry?
GTK Wave, they use GTK Wave, that much I know because I
Okay.
also had to use it
Yeah.
once.
Yeah, yeah. GTK was good. It's a very open source thing. Um, yours is Yocto and I want to say Gradle. No, there's just one more tool. Those are also open source, but they are not VLSI in itself. It's a wrapper around VLSI. It comes in the embedded domain. Yeah, it is good to learn. It's very good to learn Yocto. I also did a project in Yocto in undergrad on the ARM processor. And I built my own Linux. That's actually very good. Like knowing where your VLSI design will go to and you doing that is also good. So yeah, don't restrict yourself. VLSI na design மட்டும் தான் பண்ணணும். Don't restrict yourself. Explore. But be related. Just like, okay, is this related to the VLSI I'm doing? Sure. That's good then.
In the Yocto thing that you did, like you used like pre-existing layers, or like you set that up fully from scratch and see and converted to layers. After you used it in Yocto project. Or...
Yeah, yeah. So for me, I don't remember fully, but I think what I did was I built the system. I built the SOC. So since I built the SOC, I had to like develop the layers.
Okay.
I guess. Yeah, it was a very long time. Yeah, that was my capstone, like or milestone project. So tested me in things that I didn't know, and it's pretty good. Yeah, I see so many other questions also. Oh wait, does that answer your question, Priyanka? I mean, this
Yeah,
is
it does.
okay. Okay, that's cool. Yeah, yeah. Any open source tools, like I mentioned, Darshan, like Open Road itself has multiple tools under it. Uh, and then there is Icarus. I think there's even this mapping thing called. Uh, I keep forgetting its name. Uh, it's a C-based compiler. It is used for System C. I don't remember its name. That's always there. Please go through that as well. It's pretty good. Okay, Siddharth Krishna, could you please tell us anything you know about embedded and communications domain? This is an entirely Rohit D's question. I'll leave it to him.
Right. So communications is also a very wide field, and I personally I can tell you what I worked on in SSL itself. So communication now, like I think KT sir is like the goat of it in SSL right now, or did they put any other faculty? I don't know. I'm not sure. So um, I worked on what? First one was a research paper on RCS, which is radar cross section reduction. So that's a pretty hot topic right now. So they're making all these fifth gen, fifth gen is already there, sixth gen fighter jets and all that stuff. So you want to reduce the amount of light radar waves reflecting off the plane surface. So technology in that field is going at a pretty high rate. So if you're interested in defense and stuff, that would be a really cool place to start. And the next one was reconfigurable meta services. So this is for a 5G and 6G communication. So we know that like line of sight are good like 3G, 4G na, like it can bounce off buildings and stuff, but in your 5G and 6G, the light will lose a lot of its energy if it's not line of sight. So you might want to rotate the antenna and point it at the person who's receiving it. ஸோ டிரான்ஸ்மிட்டருக்கும் ரிசீவருக்கும் டைரக்ட் லைன் ஆஃப் சைட் இருக்கணும்னு ஒரு இம்பார்ட்டன்ஸ் இருக்கு. ஸோ நம்ம டிவி ஆண்டனாலாம் பார்த்தா டு த சேட்டலைட் இட் இஸ் டைரக்ட் அட் த ஸ்கை. ஸோ யூ கான்ட் மூவ் இட்ஸ் பொசிஷன். வெராஸ் நம்ம யூஸ் பண்ற வைஃபை ரூட்டர்ஸ் அண்ட் ஸ்டஃப் ஆப்வியஸ்லி நம்மளால ரொட்டேட் பண்ண முடியாது. ஸோ ஹவு டு எலக்ட்ரிக்கலி change the orientation of the antenna. So mechanically, physically, it will be in the same place, but நம்ம வந்துட்டு அதில் we integrate pin diodes in the antenna. So there'll be like around 20 or 30 very miniature antennas, and you pass electricity through it and change its physical properties. So that's a pretty cool topic you can work under. So on the project நான் பாதியில் விட்டுட்டு வந்துட்டேன் because it is pretty big. So I completed only the uh, MATLAB part of it, the antenna design. And the hardware part of it involves using FPGAs. So you have to control that antenna at very high speeds because you may be having like multiple users in different places. So LRQMA, you want to send data at let's say 1 gigabits per second. So imagine the speed at which it should operate. So adikla they mainly use FPGAs, and that's a pretty hard thing to do. So you can research on that field. And for embedded systems, right now the hot topic is Edge ML. You might have heard of it. So like now it's all about data collection. So your smartwatches, your phones, health tracking, monitoring, security features. So adala, instead of sending all the data to the cloud, you want to do processing of the data in the device itself. So ellame low power, low cost applications. So there's a lot of research going on in that field. So you can start off with simple implementation of machine learning in your Raspberry Pi, and then in your microcontrollers. So that could be a good start in your embedded. If that answer your question. You want to avoid software coding? What kind of
Damn.
how? I mean, then you there's always a little bit of coding in everything in this current age. You cannot escape coding. I mean, you go to a chemical engineer, he'll be using MATLAB. Mechanical engineering, they use MATLAB, and maybe a little bit of ANSYS and stuff. All of that involves coding. So you just cannot escape coding. Like specifically, what kind of coding do you not like?
Yeah, I'm
If
guessing
you
it's more like I think he's trying to mean like the IT world, like all this JavaScript and all.
like competitive coding na adalla like that won't be used. Like
Oh,
that one code forces are
yeah.
like that
Yeah,
is a
அதான் bro.
valid
Like
thing when you're
he's
using
trying
it.
to
Then
go that mainstream software development, like the MongoDB and all those.
oh yeah, those and
Yeah,
all won't be used. So don't worry.
அதெல்லாம் அவ்வளோலாம் போகாது. ப்ளீஸ் நோ
Yeah,
சி தோ. சி இஸ் த பிரெட் அண்ட் பட்டர். எதுனாலும் சி தான்.
as embedded
Embedded,
communication, you need MATLAB and C++.
yeah.
Continue.
C is bread and butter for embedded. Any embedded it is C. I don't know இப்போ C-ல there might be different wrappers, but எல்லாமே C தான். வெரிலாகே C தான். C-க்கு மேல ஒரு wrapper அவ்வளவுதான். It's everything is C. So no C, I think.
I mean, you can now write another HLS, high level synthesis. So
அதுவும்
if you
C
don't
தான்.
like Verilog also, you can now type it in like one C then yeah C.
Yeah, C. Um, uh,
I think we missed a question in the middle. Like Sridhar Anna has
yeah,
asked for Rohit D Anna.
yes.
What
What
got you
got you to
to?
actually quit a job and pursue it? Okay, this is
Hitting the hard base. Okay. So yeah.
okay. First, first talk about the. I want a job because let's say financial freedom. I didn't want to like still depend on my parents' money and do it. So like I wanted the financial independence. I wanted to do whatever I want to do, and so I wanted to work for 1 or 2 years, and then I was interested in hardware and software. So thanks to my previous job, I realized I liked only hardware. So it gave me a lot of motivation to quit my job and go for masters in ELSA. So I actually wrote. I spent almost 2 lakhs last year on applying for colleges. Like without Rohit Ram, like it wouldn't have been possible. He was giving me model and
சும்மா
yeah,
உடனே
all the support. He was there for me. So first I wanted to go abroad only. So I applied for like 5 or 6 colleges in US. I didn't want to go to Europe. Instead of studying in Europe, I prefer studying in India itself. So in US, I applied for. I forgot the list. I got into Texas A&M and UCSD. So I was
கிடைச்சு
kind of
இல்ல
happy.
அப்படின்னு உட்காந்துட்டான்.
Another,
கிடைச்சு இல்லைன்னு உட்காந்துட்டேன். I don't know.
so I did not prepare for it. I was like, fine, I'm going to the US and let's go abroad now. But then my parents are totally against it, and Trump also happened. So I had to get to நான் படிக்கல எழுதல எழுதுனா படிக்காம and then this HT was there, so I had like 2 months to prepare for it, and I wrote this, and somehow, luckily, the other people didn't do well. I got it by miracle.
Hmm.
So that's why I'm in India. So life threw a lot of curveballs. USA, India, all those issues. I also wrote cat for some reason. I do not want to get into that. That was a weird time in my life. I was very confused. So the main reason I chose India was because of my parents and like financial issues. So I am in India. That's it.
Fair enough.
Do you
So
have any other like?
you said you went to Texas, Leah. Like you
No,
had the opportunity to go to Texas.
yeah, yeah.
I'm guessing you needed an LOR for that. A couple of them.
Uh, yeah, I wrote GRE, TOEFL, and then I got LOS from KT Selvan sir and Gino sir,
How
and
did
then
you get your LOR from Katie?
what do you? What kind of question is
அதை
that?
பத்தி கேட்காதீங்க அவன்கிட்ட.
How did you get it? I want to know.
ஏதாவது வரணுமா? ஏதாவது வரணுமா?
One more illa. All I did was take his class. That's it.
Oh, okay. So for criteria is you have to do a project under him for him to give you an LOR, and you have to be good at. Yeah, he is very critical on all this. Like, நிறைய பாப்பார் அவர். So I worked with him for 1.5 years. So that's why he was ready to give me an LOR.
Yeah. Oh,
It,
yeah, you.
Yeah.
How are you? The US Rohit. US Rohit. How are you?
Yeah, I'm fine. I mean, yeah, நல்லா தான் இருக்கேன். How are you?
Fine.
Nice.
Got a job. Quit a job.
Oh, damn.
All in a
Rare.
span of 4 months.
Okay. Yeah.
Couldn't even use
Quitting.
Vivado. Couldn't even use Vivado. Server access கொடுக்கல.
Vivado is free தானே. You can download.
அது okay, but then when it's connected to a board that you're supposed to be using, so I had to ask someone else to do it for me, and then yeah, it was a mess.
Oh, okay.
That was a mess. And
Yeah.
yeah, the board had some abysmal documentation.
Yeah, documentation is bread and butter, and I can't do anything about it. Data
Yeah.
sheets, documentation.
One of the
Yeah, okay.
proprietary standards. Do you even have proper documentation for CUDA internally?
You have it externally. Why would you use the internal
Uh,
one?
Like, some of their newer features they start coming in, yeah. They start updating things. Do you even know ahead of time? Okay, what's this supposed to behave like?
Okay, so one thing about I am in pre-silicon, right? So I don't know
Yeah.
what's happening in the embedded space. I mean the
Okay.
firmware space.
In general, though, NVIDIA is notorious for bad documentation. Munadi, I don't know what it's like
What?
now.
You
I
are the
don't know.
first person I've heard ever say that.
I have been looking at this. I think 2022 in the yeah.
Dude, the documentation is so good. What are you saying?
Neither
Internally is a different issue, but external documentation is very good. What are you saying?
I don't know. In any case, what you told me is what
No,
I
I
went
think
with.
I have to agree with like Sridhar Anna. In my personal like I was trying to use a Jetson Savior and like to catch hold of an older like image to flash it. That was like really hard because like legacy version track பண்றதே like it was difficult for me. And like they
Oh,
had changed the like tool for flashing, and like I had to do a lot of deep diving to find that.
oh, okay. I am very sorry, but you probably have to contact the team, whoever does it, I guess. Like there will be a contact page, I guess. அவங்க கிட்ட mail போட்டா you get a response in like 5 business days, I think. Should be all right. Yeah, I think I missed the question. Do you think Rust is coming for C? No. uh, Rust is too bloated and too overrated. No. Rust probably for software. Embedded, it's gonna be C for a while. I don't see anybody beating C. Uh, I why is Rust? Why people suddenly are saying like Rust is better is because of the memory management, right? That is the only like advantage you get with Rust. But there, I don't know if you follow this channel called Low Level Learning in YouTube. There are so many problems that come with Rust as well. Like Rust layer, there are Rust tries to prevent user error. அதுக்கு மேலயும் நீங்க யூசர் எரர் பண்ணீங்கன்னா அதுக்கெல்லாம் ரஸ்ட் எதுவும் பெருசா பண்ணாது. ஸோ யா embedded and VLSI, whichever is legacy is trying. See, people will adopt it, but C will still be there in the forefront. Yeah, C is not gonna go anywhere soon. It's not gonna go. I see for the next 5 years, C will definitely be there. அதுக்கு மேலேயும் if you want Rust basicsனாலும் you still need to know C. So it doesn't matter. Learn C and just be okay with it.
Okay, Rohit D, and I want to ask something to you. So, like for switching domains, like you were like you wanted to do masters and then you switched, right? What do you think about if someone is like going to work for 1 year or probably less than 1 year, but they are like working on side projects or like open source contributions. அதுக்கப்புறம் வந்து they want to switch to a job like to the domain that they want to. Like, what do you think about that? Or like masters போயிட்டு after that switching is only like the most probable one. What's your take on it?
I cannot truthfully answer that question because I have not tried that. Software analysis, I did not try applying for uh, hardware jobs directly because I mean I wanted to do a master's anyway, so I directly came for a master's. So I'm not sure about this question. You might want to ask uh, someone who has done that before.
Makes sense. Makes sense. Okay. Right. Okay. So, guys want to talk about like research work that we can, do to boost our resumes performance.
Research work in VLSI or like in general. I mean,
General, core domain. Like how
okay.
much they like இப்போ வந்து like if like a project that is like in pushed in GitHub and that is like very well documented ko, like something that is published in paper ko, like do you see like they consider which one, like is this is itself fine, or like they take like research papers more seriously and when you are applying for
Uh,
jobs.
okay. So the research paper definitely does have bigger power because it's like published, it's reviewed by certain folks. But if your project is really good, like nobody can say anything, right? I mean, that's always there. Uh, I would say don't think about that. Like don't think about like paper publish பண்ணணும் அப்படின்னு போக முடியாம think about just the project, right? Even a research paper is just another project that got novel. Like it's a bit novel and then you publish it. That's it. So I would say focus on the project. If you find something in the middle that was actually better, sure, definitely make it a research paper. But even if you couldn't, that's very much all right. Just make sure that you are exploring, doing technically hard stuff uh, to like measure yourself. That's probably the main thing. If you can do that, everything else will fall in line, right? Uh, See, end goal is you should know that uh, when some employer is seeing your resume, they don't care if it's a research project or just your project. They are just seeing that if you have an experience in it or not. That's what they're trying to see. But if it is a like the problem comes when there is two people have done like almost the same project, and like one person has put it in a research paper and the other hasn't, then they'll go to the research like person who's published it. But otherwise, it's the same. And if your project is novel enough, nobody else is going to do it. So it doesn't matter if you publish it or not, right? ஒரு புதுசா பண்ணா யாரும் பண்ணியிருக்க மாட்டாங்க. So you are the only person that has ever done it. So your resume is automatically the best. Like I would say, think about it like that. Yes, if you don't get any idea, but you still want a research paper, it's very good to have that experience, like how to write a research paper, like how to be there. I never got it, which is my fault. This is something that I regret from SSN. Like even in masters, I was not able to produce any research papers, although I had like many ideas that were supposed to go for a paper. Yeah, that is one regret that I have. Like I couldn't publish a research paper or get a patent or anything.
Doing a
But
research
yeah,
paper is also easier in your B Tech. You have 4 years. Sorry, 2 years. Let's say you start exploring. Yeah, you know what you want to do by third year. You have 2 years. Whereas masters, you got like 1.5 years. So you might want to keep that into consideration.
mm, yeah. Uh, see that's always there. I hope that answers your questions.
Yeah.
Question.
So, like, if you could start once again, like in college, in SSN college, so like, how would you approach, like, I remember, like, you were both telling last time, like, initially, like, you were confused between like domains, and finally, like, decided like on VLSI more than embedded and other things. So, like, if you can start again in college, like, ipo render domain kume, how would you like, approach it, and like, it'll be
Oh,
useful for me.
between embedded and VLSI or
Or like
like எந்த
whatever
ரெண்டு
you
domain
like to
சொல்றீங்க?
answer. Pretty much that's what I
Oh,
wanted to ask. Embedded
okay, okay,
systems and unison.
okay. I will answer it and then throw it, I think. Yeah, so
Come on, Kamal.
first நான் yeah சொல்லு ரோஹித் ஏதோ சொல்லணுமா?
சொல்றா நீதான்.
சரி சரி சொல்றேன். Yeah, so நான் actually when I finished my 12th standard itself, I got into machine learning. Uh, I think அப்பதான் வந்து it was booming, like அப்பதான் it was starting, and I really liked that concept. Like you can a computer can like do classification and all that. That was pretty interesting. Yeah, it took me. I think first year I went like conference and all. நல்லா தான் போயிட்டு இருந்தது. Something that I would change is I would definitely be like more open towards opportunities. Uh, I was doing this thing like ஏதோ தனி மரமா இருந்தேன் அந்த மாதிரி I was doing, which I feel like I should have avoided. Yeah, I should have like figured out people who have the same wavelength, right? Like as soon as possible. I think the first year would be the best place to start. Like find people who are also interested in the same thing. Like I'm pretty sure whoever is staying right now in this call, you all probably have that some similar mindset at least. Yeah, find someone in your batch, in your class who's attended this, and then just start talking. Uh, I would say அதை பண்ணியிருக்கணும் ஃபர்ஸ்ட். அதை பண்ணிட்டு I should have been more open towards different opportunities that like professors also gave sometimes in the middle. I feel like I felt uh, I was feeling this thing where like this professors வந்து ரொம்ப bureaucratic பண்றாங்க. I don't want to do that. I want to do my own thing. அந்த மாதிரி I was in that track. which I could have avoided. I could have done some things that professors also were doing. It would have helped me like or exposure on the I didn't do that. That's something I would have changed. Other than that, I mean, yeah, if COVID was not there, if COVID was not there in the equation, the so many things could have been possible. Like many different challenges, hackathons that we did as a group. அதெல்லாம் வந்துட்டு சேர்ந்து உட்காந்து ஒரு இடத்துல பண்ணிருக்கலாம். I don't know how to put it. It was not the same when we were in Discord calls more than when we met in real person. Uh, the Discord calls were sure fun, but uh, it wasn't that. I feel like if we had met in real person, the productivity would have been better, and you could have actually figured out stuff.
Yeah, I agree.
Yeah, Iyantra, the whole point was because everybody was in one part of Chennai. We couldn't meet up and didn't do properly.
Yeah.
Yeah, one other thing is how did we choose between fields? At least for me, it was basically one reflection. Uh, I had other personal reasons also why I did that reflection, but the main reflection was do I really want to sit and do machine learning where the field is constantly evolving? Like you need so much math knowledge, and there is this possibility of you can cause real harm to people. Uh, like you can feed in by mistake, right? You can feed in like some trained data, cause a bias, and that can cause issues. Yeah. um, yeah, that was something that I feared. That's how I did that switch machine learning to VLSI. Uh, something like that will always spark. எல்லாத்துக்கும் ஒரு ஸ்பார்க் இருக்கும் அந்த மாதிரி லைக் சம்திங் would ஏதோ ஒரு டொமைன்ல இருப்போம் ஏதோ ஒன்று பிடிச்சதுன்னு பண்ணுவோம் and then something would have changed and then you would like start searching for the real domain and then you'll come to this. எனக்கு இப்படி இப்போ ரோஹித் சொல்லுவார் அவரோட எக்ஸ்பீரியன்ஸ்.
Um, what would I change? Um, I would have wanted to approach professors like from the starting itself instead of being like scared or shy. Like be more vocal and try to like learn from them. So that is what I'm doing here right now. So I'm trying to fix those mistakes. So right now, as I said, like approach professors and try to do different projects. And what was the second part?
How did you choose your domain?
அதெல்லாம் go with the flow. I don't take life that seriously. It's just whatever I like, I just do. I can't. I'm the wrong person to talk about like choosing domains. It's just that one thing I know for sure is if I do something, I want it like as a physical object, like some primal instinct, I guess. I don't know.
Hmm.
Like if I want to make a device or I want to make a product, and it should be a real life thing. So that's what kind of made me go into the embedded and VLSI field instead of software. And specifically VLSI because I felt the coding and the testing methods were like I found it more cooler than embedded. No offense. Like thinking parallelly and then not like sequentially, which I've been doing in software. So like answering Sri, this is where I can answer Srina's question also. Yes, so like those 2 years, like it was all Java, Angular, Spring Boot. So I learned all those frameworks, but it was always sequential programming. So what happens is like from one line it goes to the next line, whereas in hardware it was not like that. So the first week of joining Bits here, I literally had to ask Rohit Ram like how to make an FSM because I literally forgot that. I was having some issues with some simple cyanide detect. What is that?
Detector,
Detection, something. I was that bad, but
sequence
I
detector.
just, yeah, like You do have starting troubles, but if you have experience and like if you remember what you did in college and stuff in hardware, you'll easily get it back again. So that will not be an issue. It's just starting troubles. That's it. And you'll get back your flow, just like playing a sport. You leave that sport for like 5 years, you play for a week, and you get it back. That's it.
It's a muscle memory kind of thing.
Exactly.
Yeah, I think that answers Reva's question also.
Yeah.
So like we do have computer architecture in our syllabus, but it's like more diluted than what you people had, like at least in like our regulation. So like if you could suggest some good courses on computer architecture, because like I remember you people had done some courses in right, for computer architecture.
Oh, that one. Okay. Actually, to be honest, for computer architecture, just read research papers. I thought doing courses and all were the like that's how you do learn computer architecture, but no. Know the basics. I think you're asking for basics, so I should be telling learning research papers. Um, yeah. I think இப்போதைக்கு என்ன they're teaching the pipeline, like in fetch, decode.
Like we
Uh,
had all those things, and like we had like MIPS architecture also.
it's architecture.
RISC
Oh,
5
okay.
MIPS.
Okay, just the ISA, like how
Ah,
does the instruction work? Kind of like,
yeah.
okay. Yeah, that is the basic, right? That's how it works basically. Uh, அதுல இருந்துட்டு I will go one step further and read like the Patterson book, David Patterson, uh, Computer Architecture and Organization. I think that book is pretty good. Uh, I mean, I also didn't read that book. Like நானும் அப்படியே ஒன்னொன்னா like அதுல ஏதாவது ஒரு சாப்டர் பிடிச்சா மட்டும் I'll just go there and then I'll just look through it. That is very good. But then if you know this, if you know the pipeline architecture at the back of your hand, like if I suddenly ask you like a CPU wants to put a bubble, where does it do it? You should be able to say it's in the decode stage. Before the decode stage, it figures out and then it just starts pushing bubbles. If you know like avlo, if you have that back of the hand knowledge about pipeline architectures, then start reading out of order processing. From out of order processing, I will go into all the other things that Intel did, branch predictors, uh, load store predictors, and then in out of order processing itself, there were like multiple different advancements that happened. Uh, yeah, but if you know till here, it is more than enough. Also, learn about cache coherency. Uh, Coherency topics, coherency and concurrency. So coherency is like you decide how to send memory from one processor to another processor. All this, right? Also learn about that memory table. Uh, so when you type so move $8 comma address space in register, you understand how it works. You understand how it works in a CPU. But how does your operating system move from that instruction to actual binary? There's something called this virtual memory paging and table. Uh, yeah, I think yeah, many people should be knowing this. Uh, you know why the x86 and like why there's this thing called 32-bit programming and 64-bit programming? It's because of this memory page table. So in 32-bit programming, people who have taken this 8086 thing, you know that you have in 8086 you have 16 bits for address. 16, yeah, 16 bits for address, and then 8 bits multiplexed 8 with the data, I think. I don't know, I might be confusing with the 8085.
We had 8051. So not very sure.
Oh,
Yeah.
oh, damn.
Yeah, I
Okay.
don't think these guys had 8086.
Yeah, even with 8051, right? I think it's an 8-bit processor. Uh,
That was an 8-bit processor, correct.
Yeah.
Yeah, so in for the whole 8-bit thing is basically your address. You have 8 bits to do addressing, and then for data, you have 8 bits that you can interface with. So in 32, you have in 32-bit, you have 32 lines to for each application. So you open Notepad, it has 2 power 32 size memory. If you open anything else, it's 2 power 32, right? How does the OS figure out that which 32 memory is for which application? That is a very interesting thing that that people should know basically. I mean, people who want to get into computer architecture, not everybody else. I mean, if you're a software developer, it actually really helps if you understand all this. You'll write like really good software. But yeah, I guess you don't have to worry about it. That's why there's an abstraction on it. Uh, yeah, that's it. இது தெரிஞ்சாலே it's a very big thing. If you can answer these questions in an interview for if you get an off-campus job and then you can answer these questions, people are people are going to be like வாய பொளக்குற அளவுக்கு இருக்க கான்செப்ட்ஸ் தான் அதெல்லாம். So yeah, don't shy away from research papers. If you can't understand something, try asking GPT. For understanding it is okay. Just don't ask it code stuff. Like yeah, I think there's this thing for perplexity, deep research. It's able to like give you like or a detailed understanding about a particular topic. But you still have to read papers. That is always there. Just make it a habit. Like learn like reading papers. It's pretty good. Yeah. I does that answer your question? I think I went all over the place.
Yeah, no, like it's really informative. Thank you. So, yeah, previously we talked about like how risk-free architecture is coming up and other things, right? But இப்போ வந்து like if you are looking for startups in India, yeah, definitely like a knowledge about risk-free architecture and working on that, that is like considered really good and important. இப்போ வந்து if like for MNCs and all, like how is it like they consider like ARM to be like, to like if a person knows like arm like in more depth like more than risk fight, do they consider that as more valuable to their company, or it's not?
Uh, I mean, ARM is basically risk only, right? I mean,
Yeah, but still,
so
like I am talking about the like actual implementation and like when you are using it for like இப்போ வந்து like the practical use cases la when they are using, there are some differences in the like using like இப்போ வந்து there are different modes of like operation la, like risk file la வந்து we have the S mode and M mode and the user mode, and like that can be different from like how it's in a Cortex M3 or M4. அந்த மாதிரி I'm talking about small
yeah,
difference.
but yeah, that's always there. But in general, you always have this super privilege mode, and then user mode. That's there in every processor, right? So yeah, you learn one thing perfectly. You learn risk-free perfectly, ARM perfectly. It's transferable there. You can figure out. See, basically, risk is open source version of ARM. அவ்வளவுதான். There isn't anything different about it. Other than that, like professors can use it, and ARM only industry people can use it. And ARM has a developed ISA. It has thumb Thumbi instructions, and then there is this vector processing that ARM can do. So it's kind of like think about it like levels. Like you finish risk, and then you go to ARM. You finish ARM, uh, and then if possible go into x86. Uh, yeah, but I would say like treat it as like a level thing, because whatever you're going to learn in risk is not going to go to waste. It's just going to get superset. Like it's going to be a subset of a superset in ARM. Like ARM will just expand it better. You just need to know like how they are doing that correlation. அது தெரிஞ்சாலே I think it's more than enough. And from industry standpoint, like you say that risk-free, they are well and good with it. They're like, yeah, risk-free, I can train you a bit more, just like tell you to like learn a bit more data sheets, and then you are pushed to ARM. It's hard for them to, but if you learn ARM, it's very good. Like you know already all the thing, they'll be like, okay, you know it, I'll just get you in, and then we can start. But at least like learn some ISA. Like let it be x86 or like RISC V or ARM. It doesn't matter, but just learn something because it's all transferable. At the end of the day, it's all computing. It's all bits. It's all ones and zeros. It's just the way how you process it. So doesn't matter.
Very
Okay, so
philosophical.
okay,
Yeah.
mm, uh,
இல்ல இல்ல அதான் அதான் it's philosophical at this point. Yeah.
okay, so for placements and higher studies, like how much you'll say is like the decent CGPA level you should maintain.
Uh, I shouldn't be answering that. Rohit.
I mean, for highest studies in MS or like masters in US or India, like specifically.
You can answer both. Anyway, it will be helpful for others.
Okay, US. I mean, uh, number class every இருந்துச்சு like average around above 8.5 you're safe, right?
About 9. I mean, because it was
Oh,
COVID.
9.
So,
Oh yeah.
yeah, I was the outlier. So,
Whereas in India, like only your if you're going for the gate, then 6.5 is enough for gate, and even work experience does not matter in India. So if you're gonna do your masters in India and you necessarily don't want to work for 2 years, then you can directly go for masters by writing gate. Whereas for placements, above 9 is definitely like a good thing because certain few companies set 9 as the limit. Like even in bits, like few companies set 8.75, like stuff like that. So it's not just in SSL, it's true in all colleges where your CGPA can get you into the shortlisting process. So you have to aim for at least 9 in India. In US, growth can tell.
yeah, none of that here. I'm so happy. Yeah, not much of it here. I mean, yeah, it's out of 4, right? So 3.5 மேல இருந்தாலே போதும். 3க்கு மேல இருந்தா decent. 3.5 மேல இருந்தா you're all right இங்க. Uh, as for like masters to US வரதுக்கு எவ்வளோ CGPA is I would personally say 8.5 மேல 8 actually நான் 8.49 so I was an outlier. I would say have more than 8 and then it's a balanced profile la. So they are not only looking for your CGPA, they're looking for your projects, they're looking for your overall contribution and all that. They are assessing your profile like they are looking at it from a round view. So it's not just your CGPA. CGPA plays like a 40% role, but it's more like cut off மாதிரி. Okay. ஒரு cut off அதுக்கு மேல பண்ணீங்கன்னா the percentage will increase will decrease அந்த மாதிரி தான். So yeah, a good ballpark is 8.5. 8.5 மேல for masters in US. 8.5 மேல இருந்தா நல்லது. And on top of that, you still need like good projects. Research papers definitely help. Uh, yeah, good SOP, good recommendations from professors. Yeah,
If you had like would that help in
yeah, that is
offsetting if
even
you have low
better.
CGPA? Yeah.
Yeah, that is also there. But அதுல கூட you should tell like நான் workல இவ்வளவு பண்ணியிருக்கேன், like நல்லா பண்ணியிருக்கேன் அப்படின்னு அந்த மாதிரி you have to take the ball. So
Yeah. So it's not the end of the road if you don't get good CGPA for masters in US. Like you can offset it by other factors.
yeah, it's basically just be like try to be better every time. So somehow எல்லாமே it'll increase and you'll get in. Yeah.
Yeah, I'll just quickly share my screen so that any leftover questions from the uh,
Yeah,
Google
sure.
form we can wish. I hope it's visible.
Yep.
I mean, it's higher than what I expected. We got 8 responses.
Oh, nice. Okay. Please suggest some trustworthy, free, and open source to learn about electronics from scratch. If it covers from the very basics, it will be very helpful. Okay. I don't have a roadmap. I mean, if I had that, it'll be very useful, I think. Uh, is there a roadmap?
Not sure. Yeah.
Yeah, I just go from ESP, then go to Arduino. From Arduino, go to RPi, BeagleBoard or RPi, and from RPi, start interfacing sensors, different sensors, humidity, uh, temperature. Uh, what's that? Yeah, so many other actuators as well. Stepper, go to PWMs, learn PWM, and then try to start abstracting. I think go from Python to C, and then from C to start going low level. Like if possible, go to assembly, but I know it's pretty hard. Yeah, I think that's treat it as like a level. I think that's probably what I would say. I Yeah, this is a question for me. Okay, how is work life balance at a core company? Not good. Uh, it's a Saturday today, and I'll probably have to work. Uh, but it is better. In the long run, it is better. I mean, It's not like the company expects me to work. Okay, I'm not saying that. It's just that I want to work. I like working, so I'm working right now. Yeah, there is so much difference in MNCs between India and abroad. Uh, I have personally heard that uh, some MNCs in India, because of the culture there, not just because of the company policy itself, but because of the culture of people around you, uh, your entire experience will differ. So it isn't much, right? Like company policy is what matters at the end of the day. But then, uh, please do note that uh, there is a difference, and you should live with it. That's probably a problem. What's the salary curve? Uh, okay, so there is this thing called individual contributors level. It's there in all the top design houses. You have IC1, IC2, IC3, IC4, IC5 till IC7. Uh, when you are fresh out of bachelor's, you're called an IC1. For IC1, you have a standard pay package, and that pay package is based on which country you work from. So if you work in India, you'll have one salary, and then if you work here in the US, you have a different salary for IC1. And then 1 year down the line, you become an IC2, which is basically after you finish if you join after your masters, you join as an IC2. I am an IC2. It'll be more than IC1. It'll actually be the gap will be actually be more than what a regular promotion will be. Um, yeah, I don't want to discuss what my salary is, but the curve is pretty high. With masters, the curve is pretty high. But if you're joining as a bachelor and if you work for like some 2 years, you'll probably match it if the company has fair pay, like it has like a proper performance metric and all that. You'll probably match it. Uh, you will get the same amount of salary based on your country. Uh, yeah, I think that answers that question. What do I get to know on this PC journey? Is it difficult? How do I choose my own domain? What are the skills I need to develop on my own that is useful?
I
I
think we
think
covered
one,
most of it.
yeah, yeah, three. I think we didn't cover. Uh, is it difficult? Uh, I don't know. It wasn't difficult.
Wait, what is difficult? Higher studies are
Like
what?
ECE journey. I think that is the question.
I mean, if you hate EC, that's difficult. Whereas if you like most of the subjects, then you'll enjoy it. Like I personally hated a few like TLWG and electromagnetics surprisingly because COVID, I guess. Majority will
But
enjoy it because
you
I
were into
hope
antennas and you hated these two subjects.
yeah that is that's what's very surprising.
Yeah.
It was I guess because of COVID, but then maybe if I was in class I would have enjoyed it more.
Yeah,
So
that's always
yeah,
there.
yeah. I hope like you joined EC because you liked it. Otherwise, it will be very painful.
Yeah, you joined EC because you didn't get CSC, then that's
Yeah, cooked.
sorry, buddies. It's gonna be a very tough ride.
How do you choose the domain? Like we spoke about all
Yeah,
these, right?
Yeah, we spoke about all this.
damn, this is so technical. Thank you, whoever put this. Are we at a bottleneck in terms of transistor size and performance? And is the industry approaching a saturation region since different approaches to computing is in development? Yes, Moore's law is dead. Uh, for people who know what Moore's law is, the phrase is very, it's a very hitting statement. Like for people who don't know what Moore's law is, Gordon Moore was the one who who founded Intel. He said this law where every uh, 2 years your performance of your compute will become 1.5 times how it was before. I'm probably messing it up. I'm saying some wrong number, but basically number go up every year. That is what Moore's law means. Uh, yeah, that was because transistor size kept decreasing. It reduces less power, lesser power, and better compute means you're getting square root levels of performance. That's how it is. But now, yes, we have reached a point where we are not able to reduce the size of the transistor itself. Uh, and transistor itself is now technically not in a conventional sense. We have uh, it's not like a gate and then there's a source and drain. Now it's like you have a gate all around. You have FinFET. There's so many different technologies that's coming up. Uh, that's very interesting actually. Fabrication. That whole point, like how does it happen? You'd be very surprised. Like only one company knows how to do it. Like in this level, right? It's one company in Netherlands called ASML. Yeah. As for the second question, the industry's approach is not approaching saturation region just because of this transistor race, and then the computing is developing a uh, different part. The problem is the whole fundamental question for computing has changed. So that's why there are like different approaches to computing that is happening. Like ASICs, people who are inclined, they'll know ASICs. You'll know like GPUs. GPUs itself was technically a co-processor, right? So it is because of that only. It is not solely because that uh, transistor size நால தான் இது நடக்குது அப்படின்னு இல்ல. It is generally people got different needs for computing. You make accelerated computing, you make new devices. That's it. Think that answers that question. Getting a question there. You think they'll stack transistors one above the other, like with 3D cache? Sure, sure.
They're doing that for
They
memories now, so they'll obviously transition into this.
Yeah, only for memories though. You can't because memory is a repeated pattern. It's a
Yeah.
same pattern that keeps happening. So only for memory you can do 3D.
Oh,
I think now the hot topic is chiplet design. So you make different chips in different nanometers, and then you place it all in the same package. Uh, there's this YouTube channel called High Yield. Uh, they delit the processor and then they show you like how it is inside. They like even do an X-ray shot and say what part is where. Very interesting. It looks nice also. It looks really beautiful when you look from like a very far place. Yeah, that's always there. Oh yeah, next question. As a third year EC student aiming for roles at companies like Nvidia, what technical skill? I think I mentioned it in the slides.
True. Same thing. Yeah.
Yeah, I think all these questions were answered.
So already answered
Hopefully answered. Yeah.
pretty much. Stop sharing. Okay. Does anyone have any other questions?
When are you coming to Chennai again?
Yeah, I just came, right?
You
I think
came.
May. Yeah,
Probably one of the most inopportune moments. பார்க்க கூட முடியல.
yeah. Yeah, I mean, I also had a lot of health issues, so that's there. Terla, actually, Terla. I don't know. Probably next year,
Next
April.
year.
I want to say April.
Very well then. See you then.
Yes, sure.
Okay, if there is nothing, then I guess we can end the call. Thank you so much for both of you, like for coming to this meeting and like gracing it and like talking about a lot of technical stuff and like answering so many questions also. Like this, like way beyond what I had expected, and I'm so happy that we had it today and not tomorrow because like of Rohit Diana, he'll have his exams also. So yeah, thank you for your time and your effort that you put in for us.
Thanks for pre-pouring. Thanks a lot for inviting.
Yeah. Actually, I'm happy that people are asking questions. நாங்க டெக்
Yeah.
கிளப் எடுத்த போது கண்டுக்க கூட இல்லை எவனும். So this is pretty good.
How
I'm
it
actually
is
happy that so many
not
people want to get into embedded.
like I want to start TC classes, but nobody is coming for the classes only, and it's very difficult to find on like common hour because they are always busy with something else.
Yeah, that's yeah. HOD மேம் அதே மேம் தானே இல்லையா?
Same ma'am,
அவங்களே தான்.
Vidyalashree ma'am.
Okay. She was into tech club suddenly நடுவுல. She was like, yeah, tech club is a very good thing. Why is nobody doing it? அப்படின்னு சொல்லிட்டு இருந்தாங்க. இப்ப இப்படி என்ன ஆச்சுன்னு தெரியல.
No, no,
Uh,
she's still into TC now. She constantly encourages people to try out and like we like she'll ask us to keep workshops and other things and yeah, that's cool.
okay.
But the current second years are they have more subjects than us, so like they don't really have much of free periods or something like that. Even if they do have, they want to because of the hectic schedule, they want to have fun, which is kind of making sense.
Okay.
Yeah.
Yeah. Yeah, I can't help you there. We also had the same issue. We didn't know how to solve. So
Okay, then, yeah, thank you so much for coming. So, I guess I can end the call right now.
yes, cool. Yep.
Yeah,
See you man.
bye.
Yeah. Bye bye.
Thank you. Bye.